welcome to the RPS project. Today I'm going to look at something very simple. It's a logic gate. It is actually the HCF4030BEY quad exclusive OR gate in a 14-pin dual inline plastic package. Brilliant. What does that mean? Well, it means that it's an OR gate, an exclusive OR gate, not just any old common OR gate, and there's 4 of them in one package. It's brilliant. So if you've got a large logic circuit to make out, you only need the one package for 4 gates. Brilliant. What else can I say about it? Well, let's have a look on the whiteboard to start with, and then we can move on to the breadboard and actually have a look at see what it's actually doing. Very simple diagram of the logic. This is the IC. As you can see, it is literally just 4 logic gates. The OR gate, well, exclusive OR in this case, 2 inputs, 1, 2, and an output. So output here is A and B is output on J. That's 1, 2, and 3. VSS on pin 7, supply on pin 14. So I mean, very simple. And you've got 4 in there, so I'm only going to be using 1. I think I've set mine up for that one there, pins 8, 9 and 10. It's very simple. There are some things to watch out for. The voltage supply, 3 to 15 volts on your voltage supply. Voltage input will be it says minus half a volt to plus half a volt of VDD. So you know, but I'm going to make it quite low. I'm going to have my inputs at about 5 volts. Currents, input currents at 10 milliamps. Really, don't really be going over that. So anything like that, you can be less than that. But you know, shove it on around about that, maybe just below, and should all work just fine. So actually, let's just draw the diagram of what I am going to be doing as a proper circuit rather than just the IC, and we'll be able to see what I'm actually going to be getting up to. And here's the actual circuit. It's very simple. 1 logic gate, exclusive OR, 2 inputs. I've got 9 volts as my supply, and then what I'm doing is just using a resistor divider to give me about 5 volts, and then a couple of switches, momentary switches, so that press the switch, get an input on one or the other or both, and LED on the output. What else do you need? It's exceptionally simple, and that's how simple it should be. So let's have a quick look at the truth table of what I expect to get from this. So here we have the truth table for that particular gate. Now I've used E, F and L. You can use whichever one you want. There's 4 of them on the IC, so take your pick. That's just what I've chosen. Now, no input, no output. An input, high input on either of the 2, that one or that one, will give you a high output. Of course, it's an OR gate. But with this one, if you have 2 highs on both inputs, you'll get nothing out. It'll be low. That's why it's an exclusive OR, because it's exclusive to either one being high but not both. That's how I see it anyway. Very simple, very basic, very logical. It's a logic gate after all. So let's actually see it in action and see it do something, like, you know, turn an LED on. Okay, so I've got the circuit set up on the breadboard here. Got the IC. I'm just taking it from one of the outputs, well, one of the gates. There are, as I said, 4 on there, and I've got 2 switches and an LED. So simple enough. The circuit is on. You can't see anything that gives you any indication that this is on or off. I haven't put anything in there, but it is, there's power to it. So if I press one of these switches, at the moment you could say logic level 0, logic level 0, logic out, nothing. there's no inputs, so if I press one of them we get an output, or if I press the other one I get an output. But then if I was to press one and then using my finger, big fat finger, to press both switches, we get nothing. So there you go, simple logic. This gate, this switch input, this switched input are high, either one will give us a 1 output. Neither of them pressed gives me nothing. Both of them pressed gives me nothing. Exemplary ore. I'll tell you what, let's just hoik that one out and put a different colour in. Something like blue. Same stuff. So we've got a nice blue colour now. And again, one or other. Let's go through all these colours. Got a bunch of colours here. Red. Oh, that's not too bad. It's quite bright. I could probably tone that down by putting a resistor in the circuit. But as you can see, without any output resistor, that LED is working just fine. It just draws what it's requiring. So yeah, does what it should do. Let's try another colour. Green. Oh, it's not bad. It's quite nice. Subtle. Like I say, both together, nothing, that or that. And last colour I've got is yellow. Got a yellow LED. And left one comes on and the right one comes on, or both together and they're off. So it's left or right, one or other, and we get an output. I quite like that green colour the best, I think. Let's go with green. So left or right, input 1 or input 2, or in this case it's E or F. Gives me an output on L. Can't be simpler than that, can it really? Two together, nothing. So that's all that. So 2 inputs high, 2 inputs low gets nothing out. 1 high and 1 low as an output, whether it be one or the other. Well, you know, there you go. Simple. So there you go, the exclusive OR logic gate. What more can I say? Does what it should do. You put some level into it, you got 2 inputs, you put one goes high, output goes high. What more can I say about it? Of course, with this one, both go high or both go low, it doesn't work, get nothing out. Well, that's how it's designed. Does what it should do. Of course, setting this up, you've got to be careful that you don't put too much voltage on there or too much current. It's fairly tolerant, so it's quite a good little gate, and you can build it into a circuit with lots of other logic gates or some other circuit that requires some logic level in there. So brilliant, does what it should. It's quite simple and easy to set up. There you go, what more can I say about it? Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.